Some common terminologies that we use in theory of computation. These are alphabet. Alphabet is very basic or like unit thing. That is a symbol, finite non-empty set of valid symbols. Symbols like A, B, C or 0, 1, 2. These are the symbols that we use in while doing any problem. Then comes the string, any combination or sequence of alphabets. Using this alphabets, whichever combination or sequence we will make, like AB or AC, okay, or any combination like CAB, these are the strings formed when the possible alphabets are A, B and C. But here if we are using D and our possible alphabets are A, B, C, D is not D does not belong to the alphabet set, therefore this is not a valid string. But these are the valid strings for the given alphabet A, B, C. Next, epsilon. Epsilon is a special type of string that is it is used to denote the null strings. Null strings means the strings with length 0. It is just an empty string. So the cardinality, or that is the number of characters in epsilon, is 0. So S3, this CAB, this thing can be written as CA dot epsilon dot B. This dot is what? Na concatenation, means it is the joining operation, that is it will just join or combine the epsilon and B. So since this is a 0 length string CA epsilon B, this will result to CAB, because this is nothing, just an empty string, so it is same as being not present there, so it is CAB. Then it can be written anywhere, at the starting or at the middle, the meaning is the same, it will result to CAB. Then comes the prefix of a string, set of all leading symbols in a string. We know the meaning of prefix, means at the initial startings. In CAB, at initial we may have a epsilon, that is 0 length string, therefore the prefixes are epsilon, this thing. Then epsilon C will make as C, because epsilon is empty string, so epsilon dot C is equal to C. Then epsilon dot CA, first epsilon, then epsilon C, then epsilon CA, then we will do epsilon CAB. So epsilon CA, again it is CA, and then epsilon CAB is same as CAB. Then similarly the suffixes, means whatever it come at the back, set of all tailing symbols in a string. So at the last, what all characters are there in the S3 or CAB string? We may have a epsilon, that is a empty string, so epsilon, then epsilon B into epsilon, it's only B, and then similarly AB, this part, and then CAB, because epsilon is empty string, so same as writing CAB here. If length of the string is n, the number of prefixes is equal to number of suffixes, that is n plus 1. Number of characters plus 1 is the total number of prefixes or suffixes. Here in this example, the length of the string S3. The length of the string S3 is 1, 2, 3. So number of prefixes and suffixes should be 3 plus 1, 4. Therefore here 1, 2, 3, 4 number of prefixes, 1, 2, 3, 4 number of suffixes. So then substring, any sequence of consecutive symbols over the given string. The whatever combination of characters we will alphabets we will take, they should be consecutive to each other, and this can be treated as the set which is suffixes union prefixes, the set of these two. And there are some other symbols also, only in the case of 3-lettered string it is suffixes union prefixes, but for other longer strings we will have some other strings as the substrings. So substrings of S3, it's epsilon, C, Ca, Cab, and B, Ab. This is all. How to find out? Cab, any possible consecutive symbols. C, A, B, single length. First we will write the zero length strings. Then here A is missing. Then strings of length 1, that is CAB, CAB. Then strings of length 2, CAAB. We cannot write CB or BC or BA or AC because the either they are not consecutive or they are not in the order, like from left to right. So epsilon is zero length string, then the single length string, then strings of length 2, CA and AB, CA and AB, then strings of length 3, 1, 2, 3, the whole string CAB, it is written. So we have got the substrings of S3. Now number of substrings. Number of substrings is summation of m n plus 1 if n is the length of the string. So because here we have to consider the strings having length 0, length 1, length 2, so that will result into summation of n and then plus 1 because of the null. This summation n results from 1 to n, and for the 0 length string we have to write it as plus 1. So the formula is n into n plus 1 by 2 plus 1. Next is the power of an alphabet. It denotes the number of length of the string. Here summation n means it is a set which contains all strings of length n. Like summation 0, it means only 0 length string should be there, that is epsilon. If my possible valid alphabets are A and B, valid symbols A and B, then summation to the power 1 means only strings of length 1 should be there, that is A and B. These are the only possible single length strings. Then summation to the power 2 means A, AB, BA, BB, means these are the only possible strings of length 2. No other possibility is there. Next, this is clean closure. This symbol, this here star, means clean closure. Means it is the set of all the strings defined over the alphabet where length of each string is at least 0. That is 0 or more, greater than equal to 0. Means this is a set which will have the strings of 0 length, of length 1, of length 2 up to length n. That is, it contains all the possibilities of the strings, all the possible strings. Then this means positive closure. Here we have a plus instead of a star. Then this is the set of all the strings defined over alphabet where length of each string is at least 1. At least 1 means greater than or equal to 1. Minimum length of the string is 1. So this clean positive closure will have strings of length 1, also of length 2, 3 up to length n. And from these two definitions we can conclude clean closure is equal to summation union of the 0 length string and the at least 1 length string. So this is equivalent to epsilon and this remains the same. These are the two main results that we get. Next is the language. As discussed earlier, language, it is the set of strings defined over the alphabet. Means it is the collection of all the possible strings. If my alphabets are A and B, then this is a language where A, B, any combination of strings. And here L2, this is not a language because here only A and B are my allowed symbols, but here I am using C, which means this is not a language, not a valid language. Then L3, it may have a format AN and BN, so where n is greater than equal to 0. So it may be any format or without any format. Here any language L, for any language L, it is a subset or equivalent to the clean closure. Like this can be less or totally equivalent to the all possible strings language. Now grammar. The set of rules to generate strings of a language. Means these are the productions. We will discuss ahead about grammars. For the time being, it is made up of 4 parameters. V means variables, the set of variables that we are using. For example, here we have only one variable, that is S, always denoted by capital letters. This is T, means terminals, means where the parse tree will end, that is small letters A, B, these are the terminals. P means productions, some rules like this. S derives ASA or B, and then S is the start symbol. Here this is the start symbol. Then automata, a recognizing model or device, that is we will study ahead finite automata and all. These are the models or devices, means diagrams, using which we will see whether a string is accepted or not.